Okay, so we just want to be reminded of a few formulas from pre-cal. So these formulas here you should kind of remember from pre-calculus. You have x equals cosine theta, r cos theta, y equals r sine theta. Here you've got the equation for a circle centered at the origin with radius equals r, and tan theta equals y over x. So that you should recall from your unit circle, also maybe your directional angle when you were thinking about vectors, things like that. I do apologize on here that when I converted it to a PDF, some of the thetas, you'll have to notice that I had to like hand draw in there. They should have been in there, but they didn't transfer. So apologies. They should be correct on the worksheet in front of you though. Okay, so let's just take a look at example 2. We're going to convert the following equations to polar form. So remember, you can replace a y with r sine theta from up here. So instead of a y, I'm just going to replace that with r sine theta, okay? And then equals 4. And then from there, you want to solve for r, so you would divide both sides by sine theta. So if you divide this by sine theta and divide this by sine theta, okay, you would end up with r equals 4 divided by sine. So you could think of this as 4 times 1 over sine, and 1 over sine is, of course, our friend cosecant. So you could rewrite it like that, okay? And then over here, you've got the standard equation for a circle. So here, this would be a circle centered at the origin with a radius of 5. And we know that x squared plus y squared can be replaced with an r squared. So I'm just going to take that term right there, and I'm just going to replace it with r squared equals 25. And that, of course, would mean r equals plus or minus 5. So another thing we can do is kind of convert from polar to rectangular. So in this example, we've got r sine theta equals 3. Well, if I wanted to graph that in rectangular, well, I know that r sine theta, well, that's just another way of saying y. So I've got y equals 3. And so what I want to do there is then I can just graph it. Oh, sorry, I just want this. I just want to be able to graph it on there. So the line y equals 3, well, that's just a horizontal line at y equals 3. So if this is my x-axis there, then I would just go up 1, 2, 3, and this would be the line y equals 3. So then you're able to take something that is in polar form, right, this line here, and then graph it as if it was in rectangular. Okay, so I'm just going to darken up those axes right there. There's there. Okay, so again, we'll just kind of darken up the x and the y-axis on each of these so that you can see them a little better. Okay, so next up, what have we got next? So we've got r equals 2 cos theta, and so this time what I want to do is I want there to be an r cos theta, right? Like I kind of wish that that r was on the right-hand side with the cos, because then I'd be able to replace it like I did in the previous example. Well, the only way I'm going to get there to be an r cos theta is if I multiply both sides by r. So if I multiplied both sides by r, I'd have an r squared on the left-hand side equals, and then I'd have 2 r cos theta. So I'm going to kind of multiply both sides by r, so you'd have 2r cosine theta. Okay, and now I've got something useful, because now r cos theta, remember, can be replaced. R cos theta is equivalent to x. So really now I've got r squared equals 2x. Okay, then what can you do from there? Well, I want to get this in terms of x and y, so that means I need to get rid of this r squared. Well, what can you replace r squared with? Well, according to those formulas from pre-calculus above, r squared, well, that's just x squared plus y squared. So I've got x squared plus y squared equals 2x. And then you're thinking, how the heck am I going to graph that? Well, here's a little skill you haven't used in a while. Remember completing the square? So for completing the square, remember you get your x's and y's both on the same side. Keep your x's with your x's, your y's with your y's, and your numbers on the other side. So let's see, I'm going to be left with something like x squared minus 2x plus a blank, okay? Then plus y squared, okay, equals, well, there's 0 plus a blank. And this you can remember from pre-cal. To fill in the blank, you half this term, then square it. So half of that is -1, but -1 squared is 1. And whatever I add to one side, I have to keep the equation balanced by putting that on the other side as well. Okay, so let me just scooch this right up so I got room. Okay, and then from there, I can go ahead and write this as a quantity squared. So that first part factors into x minus 1, quantity squared, plus, if it's easier for you to see it, you can write it as y plus 0, quantity squared, equals 1. And hopefully now you can see that that is indeed a circle with an origin at 1, 0, and a radius of 1. So now that I know that, you can go back up to the graph from above, and I can kind of zoom in on that. Let's see. So if I zoom in right here when I go to graph it, so I'm going to put, you know, the origin was at positive 1, 0, so I'm going to do it in blue so you could see it. So here's my center of the circle. I'm sorry, did I say origin? The center of the circle was at 1, 0. It had a radius of 1, so I go 1 to the left, 1 to the right, 1 up, 1 down, and then you can kind of sketch in a circle right there. Okay? So, I know that's kind of small on mine, but hopefully you can kind of zoom in and see it. Okay, so then what do we got left? We have this theta equals 2 pi over 3. Okay, well, what do we know about that? Well, I know that if I had tangent theta on each side, right, then I could introduce an x and a y because I know that tan theta equals y over x. So basically what I'm going to do is take the tangent of each side, so whatever I do to one side, I got to do to the other. So if I tan both sides, I'm going to have tan theta equals tan of 2 pi over 3. And hopefully from your unit circle, and that's an equal sign there, hopefully from your unit circle you would recall that the tangent of 2 pi over 3, so think about it, you're over in quadrant 2, okay, and so it's going to be a negative, okay, tangent's negative over there, so I'm just going to go down here. So tangent of 2 pi over 3 is negative radical 3, okay, and then the left side, tan theta, well, we already said that tan theta is y divided by x. And that's useful because now I have an equal sign with an x and a y. I'm going to solve for y. So multiply both sides by x. And if you multiply both sides by x, you get y equals, okay, negative radical 3, and then the x outside. Some people might even write that x more towards the left so to make sure that that x doesn't look like it's underneath the radical. So you've got something like that. Now, that is not the most beautiful line in the world, but it's still a line, right? It's y equals, and it's just got a slope of negative radical 3, so it's not pretty. When you plug in x equals 0, you get y equals 0, so it does indeed go through the origin, okay? So it goes through the origin, and then it has a negative slope of radical 3, so I'm just kind of estimating it there, right? But we're just going to say that that slope is negative radical 3. Not the most beautiful thing, but those are 3 examples of you converting from polar to rectangular, so if you wanted to graph them that way. And then we'll take a look at the next page. Okay, the next thing we're going to do is we are going to derive a formula here. So it says, to find the slope of a tangent line to a polar graph for r equals f of theta, we can use the facts that x equals r cos theta and y equals r sin theta together with the product rule. So basically what we're trying to do here, we've got dy dx, and we know from before that dy dx is dy d theta over dx d theta. That we did that the past few days. So now what we want to do is figure out what does that mean in terms of polar. Well, let's first take a look at this top part here, the dy d theta. So since I'm working with y, I want to work with this y equation up here. And I'm going to say that in that y equation, r is my first term and sine theta is my second term. So once you have that, you could say first times derivative of the second. So the first is r, so that's where I got this r from right there. So r times derivative of the second. So first times derivative of the second. If the second thing was sine theta, then the derivative of that is cos theta. So you've got that term there. So this part is first times derivative of the second, right? Plus the second, which we already said was sine, so plus second times derivative of the first. Well, the derivative of the first, the derivative of r is just 1, but you took the derivative of something that's not a theta, so you tack on that implicit differentiation technique and tack on that dr d theta there. So there's my numerator, okay? Then I got to go on to my denominator. So the denominator is going to be using this piece. And very similarly, we're going to call r term 1, and we're going to call cos theta term 2. So you do your product rule. You have first, so the first is r, times derivative of the second. The derivative of sine, the derivative of sine is cos. Cos is negative sine, so that's where this negative came in. So you've got first times derivative of the second, plus the second, well, the second was cos, times the derivative of the first. The first thing is r, but I took the derivative of something that is not in terms of theta. So the derivative of r is 1, but then you tack on that dr d theta at the end. So this formula, you could memorize it, but it's really not that hard to kind of put together once you realize you're just using the product rule. And then a lot of the problems that you're going to use this for, they're just going to be a little bit messy, but it basically turns into primarily unit circle problems. So taking a look at example 4, it says, if r equals 3 plus 2 sine theta, find dy dx, and find the slope of the graph of the polar curve at theta equals pi over 6. Okay, and sorry, I don't know how to get rid of that stray mark down there. I don't know how it got there. Okay, so we know dy d theta. We have this huge formula for it, so we're just going to kind of dive right in. So we're going to say that dy d theta, I'm sorry, dy dx, sorry, dy dx equals, and I'm going to be using this huge formula from up there. So I need r times cosine theta. Well, I've got r, they gave me r. R was 3 plus 2 sine theta, okay? And so I got that part, and then just get rid of that. Okay, so I've got that, and then cross that theta, r times cosine of theta. So if it helps you to kind of put that in parentheses, there's my r. Now I have to do cosine theta. Well, the theta they gave me was pi over 6. So cosine pi over 6. Hope you didn't forget your unit circle. Okay, so I kind of did that part, right? R cos theta, that part's done. Plus, now I have sine theta. So sine of pi over 6, okay, times dr d theta. Now, that's what you need to think about. Dr d theta. So how are you going to get dr d theta? Well, it's the derivative of r with respect to theta. So you have to go look at this r value. So the derivative of that with respect to theta. Well, the good news is the derivative of 3 goes away, so don't worry about that. The derivative of 2 sine theta is just, well, the derivative of sine is cos. So it just becomes 2 cosine theta. Okay, so we've got that. So that took care of that part. Now it's divided by, okay, now I got to worry about that denominator. So it's negative r times sine theta. So it's negative r. I would definitely put that r in parentheses so that I didn't, drop a negative somewhere. I don't want to do that. So there's the negative r sine theta. Okay, so we've got sine. Oh, and I could be plugging in that theta is pi over 6. Sorry, I could have been plugging that in this whole time. even over here and up on the top there, because I am going to be plugging that in. Sine theta plus, okay, so that was this, plus cosine theta, which is pi over 6, dr d theta, and I already know dr d theta from before was 2 cosine pi over 6. So now I'm going to go back and I'm going to replace those thetas up here. I'm going to do that with a pi over 6. And then this one I can go back and do a pi over 6 there as well. Yes, Maddox? Okay, so now you're just going to go ahead and use your unit circle to kind of plug in. And once you get those things plugged in, okay, so you've got 3 plus 2 times the sine of pi over 6. So sine of pi over 6 is a half. Okay, so you've got 1/2 there. And then you've got that all times cosine of pi over 6. So that means that must be radical 3 over 2. Plus sine of pi over 6, we already said was 1/2. Times 2, right? Because that's 2 cosine was radical 3 over 2. All right, so there is your numerator. And I'll kind of go to the canceling in a minute. Let me just scooch this up. Okay, so then, again, this is a little tedious. It's just unit circle stuff. And so then from there, we just go to the denominator. Watch that negative. So you've got negative. And again, we're going to have something similar. We'll have 3 plus 2 times a half. And then all that times, let's see, sine of pi over 6 again. Well, that's 1/2 again. So that's this pi over 6 right here. And then plus cosine pi over 6. That's radical 3 over 2. And then times that times 2, and then that'll be times radical 3 over 2. All right, from here it's just a happy day of canceling and kind of reducing things out. So, you know, this and that kind of kill each other to be a 1, right? And then this 2 takes out that 2, this 2 and that 2 similarly. Again, this cancels out to be a 1 there. So after some careful reducing, you've got 3 plus 1. So 3 plus 1, you've got 4 times radical 3 over 2. So if you have a 4, right, times radical 3 over 2, this 2 goes into that 4 2 times. So you're going to have 2 radical 3, okay? And then plus, over here, this part reduces to just radical 3 over 2 over, then let's see, we're going to have very similar fate over here, right? 3 plus 1 is 4 times a half gives me a 2. Oh, but wait, it was negative. So negative 2. Okay, so negative 2. And then plus 3 halves. Okay, so that's kind of what I got as my final answer on that one. Again, very difficult, not necessarily, just super tedious. Keeping in mind your safe stop would have been way back here, so once your numbers are all plugged in there. But I would leave my answer like that, or if you wanted to, you know, if it was multiple choice and they kept reducing, this answer could go further. You could get a common denominator. You'd end up with something like 5 radical 3 over 2 divided by negative a half. Dividing by negative a half is the same as multiplying by negative 2. So then those 2's would cancel. Right, so if you kind of did a keep, change, flip thing, and that's times negative 2 over 1. So then this 2 would take out that, but you'd still have that negative. So your final most reduced answer, thank you, Maddox, I'm sure they loved that, negative 5 radical 3. So that would be the multiple choice, most beautiful answer there. All right, well, looks like Max wants a snack, so we're going to have to kind of pause and see what we can do after that.